Hello and welcome back to IMDB data read. I think it's number 6. In this video, we'll mostly work with retrieving data from the database and putting all of that into our Java lists. And we'll get all the connections between different objects like movies, genre, and actors. And we'll also fix a couple of issues that I ran into before, what I tried to do, and one thing that I forgot to mention in the previous video. So we will actually start with the first one. We will add unique indices to the database. Again, when we start, I want to remind you to start our database server, open up the database client. And the first thing we want to do, we want to go to both of those relation tables, go to the table data, and select both of those elements that are unique from both of those tables. And we can just simply right-click, create new index, and create a new index. And in this indexes tab, we can see that there's a new one with two like sub-elements under it. So what it does, it creates a unique combination and says that any new record that will be tried to insert it in the database cannot be inserted if this combination between these two columns is the same. If we open up, actually want to save it as well. Let's save it, and we go to the data. So if we try to insert this movie ID and this genre as a new record in this database table, it will return an exception because we already have this unique element. It's just the same thing as we did before with only one column, which was this IMDB ID. And in case of genres, it was its title. And in this case, we are actually creating a unique combination between two elements. And that is just if we read those movies over and over again, so we do not insert duplicates of these relation combinations. So if we did that in one table, which one? This we don't have. We actually select those two, right-click, create new index, and unique. We don't need to change any of the names. It doesn't matter. What we want to have is have this unique combination of these two elements. Open it up, yep, movie and actor, and combination of these two elements, both of them have to be unique. And as we did before, if we are trying to insert it with a simple insert query, we'll have an exception and we'll have problems in Java. And we will not save all the rest of the elements that will be unique. So what we have to do is go back to our database table and fix these relation insert queries, also adding insert ignore to them. Just as I explained before, if we are inserting, let's say, 100 relations and one of them is not unique, the whole query will stop and nothing will be executed. But if we use this ignore, then all the exceptions, all the problems will be ignored, and all the relations that are unique and have to be inserted in the database will be put in there. So that's the first thing I want to say. Number 2 was, so actually we did 2 points right now. The second thing I want to do when I started this 500-page read, I think I read about 100 pages, I don't remember. But on page about 18, I think, I ran into an exception where if we go back to a movie class and we go to a getMovieYear method, I had an exception of parsing this integer from the string. And the situation was that there was a different possible string that was representing start and end year. So it was something like 2016, then this, then that, then part number 3 or something. It was something unexpected, right? And that reminded me of this situation that actually, you can delete those two or not. Okay, it reminded me of the fact that always trying to take all the possible values, especially from the web where we do not work on these inputs, and we cannot control what kind of possible values there will be. We cannot know. We can find, let's say, 10 possible values, and we create a method that works with all 10 of those. But on page 276, something can break. There can be 2 of those lines, and maybe, I don't know, something different can happen. Maybe there's a 1996 to, and I don't know, or to 1999, right? We cannot always know all the possible values. And in this case, the better scenario would be to use a regular expression or regex and to simply read all the occurrences of 4-digit numbers. So in this case, we will return, with this regex, we'll return an array of all the possible values that we found. And in this case, it would be an array of one element here as well. And in this case, there will be array of two finds, because there's one 4-digit element and another 4-digit element. And if this regex returns array of 1, then we only have a start here. If it returns array of 2, then we know it's start here and end here. This would be a better scenario. You can try it out. You can Google regular expressions. These kinds of expressions wouldn't be too hard. You can definitely Google them. There are also sites on the web where you can test your regexes, and it's a good skill to know. But in this case, just to simplify the situation, I just wrapped this integer parser into a try-catch block, and if it fails, it fails, and we just return 0. And I did that just because, for me right now, these movie years are not too important. Also, we know that not all of those movies have these years, so some of them just didn't have this data, and we are not going to get the perfect result anyway. So I just, for the simplicity, just had a try-catch block. If it fails, we have a 0, and that's it. And in this case, we didn't have any problems because we are working only with this length 11, so it was this scenario. And if it's written in any kind of way, it also will return 0. This is just one thing. If you try to read it, then you should know that the code that we had before also didn't work for me. But obviously, you probably fixed it yourself, but that's just what I wanted to mention. Anyway, small things away, we have to retrieve all the data from all these database tables. So if we go back to a movie maker, where we had our 3 lists, we had an array list of all the movies, hash map of genres and actors. Right? We had 3 lists of all the 3 types of elements. But if we go back to a movie list frame where we actually generated this data into the JFrame, we can see we only used this movies list, and we worked with these elements. We open this one up. We just what is this genre? Oh, it's for the movie. We just populate the list of genres into a string. So what I want to say is, to make this visual side workable, we do not need genre map and actor map. All the actual relations are stored in this movies list in each of the movies object. Each movie has actors list and genres list. So basically, both of these two are not needed. If we want to find out for sure, we can right-click and go to References and Project, and then it will open all the references of this variable where it's used in this project. So in here we can say it's in the constructor, it's just created, initialized empty list. In the reading, it's just we are saving it and then we are clearing it for every other page. And in the read movie block, we are also creating it and putting those genres in the list. But we actually are not using the genre list, genre map at all. And actually back here you can see that I failed on page 18 and then I restarted from page 19. So back to this genre map, we know we are not using it. It's kind of useless for us. So we do not need to create these hash maps the way they were, how we used them, how we created them while reading from the web. We can use them if we want, but we don't have to recreate them exactly the same as they were before. But movie list obviously needs to be as it was, the list of movies. Each of the movies has a sub-list of actors and genres. If we go back to the database though, we can see, okay, we have all those database lists. We can save all of them in any kind of list that we need. But if we go to the relations, we can see that we will be reading those relations row by row like this. So from each relation, we will see both of these unique IDs. Unique ID for the movie like this has actor this, and movie this has actor this. So what we will need to do is from each relation, we will need to get this specific movie by this ID and actor by this ID. And the same is with movies and genres. Movie by this same IMDB ID and title by this name. So some of you might already understand where I'm going with this. We need to create lists, or actually maps, where we can get each genre, each actor, and each movie by their unique IDs. So what I suggest we would do is create a new hash map. This is only going to be a one extra list. So hash map of string and movie. This will be a movie map. And also we will initialize it here as well. And we'll just create this map just as a helper function so we can find these movies faster. We do not have to iterate through all this movies list to find movie with this ID, right? That's why we use hash maps to find elements faster by some of their parameters. So movies will have this IMDB ID as the key, actor map as well, and genres will have the title as the key, just as they had before. So that's one thing we have to keep in mind. And then from this, or maybe in parallel, we'll also populate the movies list, the actual array list that we will be using later on. So save this one. Before we go into the database and create methods that will get this retrieved data from the database, we can go back to our database example that we created in the previous videos, just to remind how the select statement looked. So we are selecting something from a query and then looping through each of the row, and by get int, get string, or get something, we are getting back the actual value that we need, passing the column name as a parameter. We can actually copy this one, and let's say we create a new one here, and we can maybe call this one read genres, okay? Then we'll have obviously 3 of them. And then we'll have two more for those relations. Okay, let's start with movies as it's like the most important one. Then genres and actors as well. And we'll be going through them one by one, but actually the idea is pretty much the same for all of them. Read movies. What are we doing? We are reading the elements and we have to save them into our list. So what we have to do is pass the reference to the list we have to put them in, right? So if we go back to the movie maker, we are creating this database. And after we create the tables, if they don't exist, what happens in a constructor, we want to do this database read elements, just read elements, let's say, okay? And then we can maybe create a new method where we call all those 3 methods, read movies, read genres, and read actors. Or we can also separate them. Okay, let's separate them because it will be easier to pass these maps for each of the methods. We'll not need to pass all the lists in one method. But it's your preference how you create it. Let's read movies and pass the movies list and movie map as well. So we have to populate both of them. So for the read movies, we need this as parameter. Going back, this. and also the map hash map. Okay. So in here we just simply read all the movies, nothing specific. And here when we are reading all these columns, we'll add the rest of them as well. We don't need to print out anything. We need to create a movie is new movie, and we'll pass in the constructor, we'll pass all these elements that we had from the database. And after that, we will say movies list, add this movie, nothing crazy. And then for the movie map, we'll say movie map. What is it? The put, and we need key and value. So key is going to be this movie's IMDB ID, this unique element that is unique in the database. And the value is going to be the actual movie. Okay, that's kind of obvious. And then as these are references to those lists, of course, we'll be able to use them in this movie maker or any other class that we have this list. So we just have to populate get all these columns and add them to our constructor. So to remind, we have a lot of them to work with. How can we do that? Okay, are we going to pass all of them from the database? Title, description, image URL. Are we saving image URL? Maybe we need a new constructor for creating movie objects from the database, but I want to make sure how it works. So we're not adding the ID, are we? No, we're not. As we're not editing those elements, we don't need the ID. But if we would, let's say in this visual Java application, if we would edit some elements, we would need to read this ID. So afterwards, it is easier to edit something specific in the database. Yes, we can go with this unique element, but it's always better to save, let's say, update title in table movies where an ID is the one that movie has. But as we don't need the ID, we can skip it. Image URL, do we have it? Yes, we have the image URL. I hope it's created in the same way as we had before, so we don't need to work with it too much. Let's go back to the movie, year string. It's not a year, we actually don't need the string. All these methods, all these elements are actually saved correctly in the database. Right? We do not need to parse something from something. We don't need to replace get movie end year as we did before. From the year string, we don't need to remove all these unnecessary elements. So we actually need a new constructor that we will be calling as we are creating objects from the database. This we can say creating movies from reading web. And the new one will be reading movies from local database. And it's a common thing that you create multiple constructors for different situations. Okay, so let's work with this one and try to figure out the easiest way how we can do that. Actors and genres will be created, yes. The title and description, we can maybe add these. Next to it. So I'll have title, description, image URL, yes. It's not going to be a year string. How are we saving year in the database? It's a double, weirdly, but okay. So we're going to say double. Is it really double? Yes, I remembered. I was wondering why I did it in the first place. You can actually save it as an integer or as a string as well. Although if you save it as a string, it will not be so easy to compare those years between two of them. So maybe integer is better, but I don't know, your choice. So year string, it's not going to be year string, it's going to be a year. Then certificate is also a string. Yep. Then length is not a string. Length is a what? Is an integer. So we're saving that. Rating is, where is it? It's decimal, so it's double. So that's rating. Metascore, I think, oh, Metascore was integer, right? Yep, because it's a 1 to 0 score. Vote string. Votes is also an integer. We have to change that. Gross string. Gross is a decimal, so it's a double. Director is a string, and IMDB ID is also a string. So what we're doing, we're adding these ones. This is simply a year. Is it, oh wait, is TV show. Do we have a is TV? Yes, we have is TV show. So we have to take that one as well. Let's put it after the year and say boolean, or let's have it as integer is TV show, and in is TV show we'll say if is TV show integer equals to 1, as it is in the database. If it's 1, it's true. If it's 0, it's false. So year is, where is it? It's the same thing. Do we have an end year? We don't. We actually need to save the end year as well. Not save it, but pass it in here. So it's an end year. Passing it as well. And length is a simple integer, and all the rest of them as well. We can actually call this one. So what do we have to do? We actually have 2 of those elements. I think we have this local image string in the database, and the image URL is, well, we actually don't need it for this one because we needed to pass it to download the images only for this file manager. What we actually need is only this local image that we'll need to populate the list in for the JFrame. So title, description, I think we have it all. Year, end year, everything, certificate. Oh, IMDB ID is not used. Oh, it is. Okay, cool. There would be warning, I think. Would it? Not used? No, there's no warning. Weird. I think there should be warning that the past variable is not used in a constructor, but maybe there shouldn't. I don't know. But I think we added all of the needed elements. Yeah, well, let's try it. So let's copy this one so we have it in the database method. Let's make it one line. Geez, it's too much for one line. Okay, so we don't need to read the ID. We can start, okay, title. Let's have the IMDB ID. And we have to see how it's called in the database, IMDB ID. Actually, it's a bad naming convention for Java. This one is here, and database is IMDB ID. Okay, title, description. Is it description in the database? Yes, it is. Moving on, local image. Equals, that's a string. And in the database, it's called, oh, it has both of them. Okay, we can pass both of them, whatever. We actually don't need this image string to be used. We can have it. this image URL for the movie object, but you actually are not going to use it, so we can just leave it in the database for now. The local image, double year as well. So basically, I think you understand the drill. You can go through this by yourself, and then maybe if you have errors, you come back and look how I'm doing it. If you don't, you can just skip this part of the video, as it is pretty boring what I'm doing right now. But you have to make sure that you are having all these column names just as they are in the database. Int is TV show. And this one is this. Get integer. Also, the method calls have to be right. If it's string, then get string. If it's double, then get double. Here it is get integer. String certificate. And if you do these kind of things for a project where you can have even 5 database tables as you have right now, it will be very soon where you understand why there are libraries for this, like Hibernate for Java, or how was it, Eloquent, I think, for PHP, where all these things are done automatically, read from the keys from the parameters of the object, and you do not need to read all of them from the database manually. But this is something that if you are starting with Java or programming at all, you have to go through with it to understand how it works. It's always better to understand how things work and go through them to the very bottom, not just use some kind of library and never understanding what actually happens in the background. This is the same as people are driving cars and they have to understand what's happening like inside them and what's in the motor, how things are working. Only then they can actually maybe, I don't know, race the cars as well. Double rating. Oh, that we have. The order is horrible here. Length, then metascore. I think I can copy all of these. And the IMDB ID we have, I think this is it. And then metascore is going to be an integer. This is a string. This is a double. And votes are votes. And metascore, is it metascore? Okay, that's true. Director is that, and gross is gross. Okay, then let's, oh, we didn't have to delete it. So we know the actual order, how we have to pass these elements. So title, description. Do we have, yep, we have local image. Then the year. Okay, there's something wrong with it. Something's not right. What have I missed? Title, description. year and year. We have all of them. I think the data types are a bit wrong. Oh yeah, of course, because it's integer. We had string, right? Usual, the regular ID was integer. That's why I had it. But here it is string. Okay, cool. Now we have this movie. We create it, and then we put it in the list, and we take its ID and put it in the map as well. Cool. We have the first one. Hopefully, there will be no exceptions with it. Problems with selecting movies. So we can see that. Let's go with genres. All the rest of them will be a lot easier. From table genres. And here what we have is ID and title. We have to open the genre. We have just the title. Yes, we can use the same constructor as we do not have any other elements. Genre doesn't have a IMDB ID, so we can use the same one. We also don't need the ID. We can actually read the title. That's the only thing we need. Actually, we have it. So in here, we can create a new genre object. Have the new one by the title. And then we have to pass this list so we know which one to add this element. Read these ones, passing this one, copying this one, pasting it in, and genre map. Put the key is genre title, and the value is the genre itself. Simple, a lot easier than the movie. And actors is almost the same. Here we also need a new constructor, as we in the initial one we do not have IMDb. Oh, we have IMDb ID. Oh, obviously. Okay, what do we need? IMDb name and profile ID. We can actually use the same one as well. That's easier. So IMDb ID, which is a string, I'll remember now. Then we have not a title, but the name. And profile URL, which we are not using, but we can read it anyways. Not the description, we have this one. We don't have these. And then actor, A is new actor. What are we passing? Name, URL, IMDb ID. So name, profile URL, and IMDb ID. What do we need to do? We need to again add this list. Actor map and read actors. We copy this one. Open the method, and we are passing this list. And for the actor map, we are putting it in, put, and the key is actor's IMDb ID, its unique element, and the value is actor itself. Not compute, I wanted put. Yes, cool. Now we have all three of them. Now we have to create these relations between all of them. And how we are going to do that? We will simply pass, let's create a new DB read movie genre relations. And we will pass a movie map and genre map. Both maps where we can get those elements by these ID that we will get from the database. from those relation tables. So we'll create a new one. What did I do? Okay. Public. Well, we actually don't need these methods as public. I don't know why I'm used to that. But yeah, they could be private as well. But as we are creating this project for only ourselves, we can afford doing that, but it's not the best way to do that, of course. If something doesn't need to be public, we don't need to write it as a public. If it has to be private, we have to write it as private. But that's for another video. Okay, we can also select, we need to select from this database. Can we copy this name? Where can we copy the name? Basic. Here we can copy the name. Movie genre. What are we having? This is interesting. We have this one as one string and this one as the other string. So now it's movie ID, we can call it that. And let's say it's genre ID. It's not actually ID, but it's ID as unique identifier for each of the objects. So movie is from the movie map, we get by this movie ID. And the same for genre is genre map, and we are getting by this ID that we retrieved before. So before we want to put anything anywhere, we have to make sure that we have both of those elements. So if movie is null or genre is null, we're going to say sys error, something wrong with movie genre relation. And let's just add both of those IDs so we know what are we dealing with. I hope this kind of scenario is not going to happen, but we have to make sure that it is. And then for the movie, we're going to add, add genre and pass this object in here. So for each relation we are adding to the movie, and if we remember this method, go back to it, then it adds its relation back to the genre object as well. So we do not need to recreate anything else. Problems with, whatever. Select MG. Problems with selecting actors. And then this one is pretty much copy-paste for movie actor relations. Actor relations. And then this is string and actor. And in here we have to have the other database table. And then one is movie ID and the other one is actor IMDB ID. Have to make sure that they're named the same. And actor ID, this one is movie, this one is actor from the actor map. Movie actor relation on these ones. And if we are adding actor by this actor. Okay, we went through pretty fast, but this is how we create everything. In the more proper situation where we would actually create a real life application, we wouldn't be working like that. What we would actually be doing is, number one, we'll have pagination, which means we'll have pages to click on the top or the bottom of the list, just as we have in this IMDB, the real database, in the real web page, right? And so when we are changing the pages, we would be actually selecting only those 20 or 30 or 50 records from this database and only showing them. But in here, again, for the simplicity, for showing this, the first actual way how to do it, I'm just reading all of it and recreating all these relations as we had in when we read from the web. But obviously, in the best situation, you are not reading everything in the application and then just using what you need. But in this case, I think it's going to work fine. I hope. So we have read everything. Oh, we need to add the other relation. So movie map and actor map. And here the method was called this. So what we did, we have the data in the database. We are taking all the movies and populating both of those lists. This one that we're going to use later on, this one, so we have easier work with these relations later on. Genres in the map, again for relations, actors in the map for relations, and in here we are reading each one of them from each database record. So in here, when we are looping through the list, we are actually looping through each relation, each combination of movie and actor that we saved before. And well, yeah, we are just connecting them through this add genre and add actor method that we created in one of the first videos. And back in this movie maker, we have to actually fix this thing. So back to the main, we are actually going to say boolean read from web is false. True is from web. False is from database. It's just a simple element. So from the main method, so we'd be able to control this, what happens in the background. So boolean read from web. So if we are reading from, if we need to read from the web, we'll say if read from web, then we have to call the web reading method. But if we are not reading from the web, we have to get everything from the database. And this one can be here, and this method can be put in here. So if we are reading data from the web, we are just calling this reading method and having everything as we did before. Where is it? This one. And saving them into the database. And if we are not reading from the web, if we are actually opening the JFrame, then we are reading the data and then creating a frame after that. I think it's ready, but I have absolutely zero confidence that there will not be any issues, because I have, as I read, I stopped at about page number 100, I think, I don't remember, and I have 4,600 movies. So it's, yeah, if we divide it by 50, it's like 92nd, 93rd page. So let's go back and let's see what happens. If we run it, we actually could have created some printouts so we can see what is being read, because retrieving all this data from the database takes a little bit of time. But let's see what happens. Yeah, we can actually add it for the future. Okay, we have it. We have the list. Everything works. We do not have these images. I think the link is wrong, or I have removed the elements from my desktop. If we click on the list, we can see everything works properly. If we click on the elements, everything is opening as it was before. So that's good. Yeah, I thought it's like a title or something. Marion Mac, it has one movie, he has one movie. Everything's working properly. We have a problem with this, with the image. I think it's read incorrectly. We'll check it out later, but at first I want to add a printouts just so we see what's happening. Okay, then we have these ones. We can just open it up and see what takes the most amount of time just looking visually. Yes, so none of these is taking any time. Actually, the populating the list takes the most amount of time because we can see that everything is done super quickly, and just populating the list is the one that takes the most time. Geez, what is that? Interesting. Yeah, it's actually interesting, even with this, without super cool visualizations or anything else. It's actually interesting to go through with it and try to find some kind of associations between different actors, different levels of the movies, different ratings of the movies. We can open comedy lists. We can see, oh, there was a family of them, and all of them, not all of them actually. Oh, here we can see interesting thing that there's a family in one movie. Two of them had another movie, and one of them was in another movie. And the best one was where they all worked together. When there were three, the rating was lower, and when only one of the family members was there, the rating was even lower. That's like weird but interesting thing to look at. But it takes a long time to close all of this. But well, this is just the beginning. Okay, let's try to find the problem in the URLs. We are having local image is that one. When we are populating the list, we have the URL, we have the slash, and then we are adding the local image, which should be right. I don't know what's happening on my desktop, but the small images, there are images. Okay, interesting why it doesn't work. Or maybe have I commented? Oh, okay, yeah. This is why it doesn't work. For some reason, I commented it out. I don't remember why. I think I wanted to try it, or we did it in previous video. I don't even remember. But this was the reason why it didn't work, because image tag there was nothing in there. Okay, so let's try again. And as we can see, we are loading a hell of a lot of movies, 4,500. And for me to read all of that from the web, it took me, I don't even know how much, like an hour, maybe 2, maybe 3. And in here it takes not even 10 seconds, I think. Or maybe now it will take a lot longer because it's loading all the images. But anyway, it takes so much less time than it took reading data from the web. And obviously, it's a way better way to run this application. We can maybe, I don't know if we'll wait for the result, because loading 5,000 images, it's not a small task. We can actually go to this one and see how much it weighs. It's 15 megabytes. It's not too much, but it's a lot of small images. Now we can see all of them. Although it doesn't look like 5,000 movies. Interesting. We could actually try to, let's see what happens. Let's not do this as it takes the most amount of time. Let's, for the interest, just go movie list, movies list. What is its size? 4,900. Okay. But in the database we have, oh, it's approximately. This is the problem. If you have a lot of the rows in Heidi, this data tab might not show you the exact number. So in here, you actually would need to call the query. Oops. Yeah, we have 5,900 movies. Weird, because in the visual frame, it didn't look like that much, but maybe it's just me. So long story short, this is how we do it. I think it's nothing super hard to understand. We are reading all the elements. We have some unique identifier to identify different elements when we have them from the big list. We have this ID, and by this ID we can tie them together with these relations. And we just added this hash map for movies just so we can find the actual movie quicker. Because if we didn't have this hash map, if we're going back to reading the relations, why is this not getting lost? Whatever. Getting the relations, we wouldn't be able to get element like this from the map. If we would be passing this movie list, we would have to loop through all of this list until we find the one with this IMDB ID. And when we do, we can break the list and then we can move on. So we would be actually looping through almost all of the list every time when we are trying to create new relation. Obviously, it's not the best idea. That's why we had this hash map. But actually later on, we do not need any of those, not the movie map, not the genre map, nor the actor map. Well, I think I will leave this at that. There's so many things that you can upgrade, you can do better. With this, you can read a lot of information from different websites, from different projects, populate your database, populate back the lists from the database data back into the Java, and create interesting projects. Thank you, and hopefully see you next time.